The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here along with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update, today on Tuesday, May 18th, 2021, a day that's more famous for another volcano in the Pacific Northwest, Mount St. Helens anniversary today. But we're going to focus today on Kilauea, as is our weekly pattern on Tuesdays here. I'm Kilauea. I'm showing you guys here in the background just a time-lapse of these sunset views of the lava lake over the whole past almost 5 months now. Where the eruption began December 20th, 2020. So on the 20th here this Thursday will be the 5-month milestone of this Kilauea summit eruption that's still ongoing. Although at present, the biggest thing that jumps out to me it's no longer clear that lava is actually filling that lake. And we'll look at the signals here, we'll look at the monitoring data, we'll look at some of the imagery, and some other time lapses we put together like this one. Meanwhile, Dane will man our chats, check our streams. We know that there's been some issues on YouTube today, so we'll keep an eye on that if we can, and try to answer what we can in the chat, and keep up with you guys in as many ways as possible. All right, so we'll do two kind of segments today. I'll go through most of the visual stuff first, and then we'll take a little break and say some thank yous, and then we'll talk about some of the data here in the back half of our update today. So starting off, it's trying to make sure we include this big picture view here today. of this 5-month ongoing eruption of Kilauea. Although we could argue when we actually decide an eruption is over and what counts as an eruption, all of that here. It's going to be what we talk about probably in the next couple weeks here. But you guys are seeing here these sunset views of the lava lake that had crusted over from the entire crater of Halema'uma'u, that summit crater within Kilauea caldera here, and down to just this western side. You can see there at the very end, it's shrunk in surface area even more recently, down to it's maybe not not an official term, right? But they look like little puddles from this vantage point, this far up above the crater rim, look like lava puddles. So really, they're small ponds, and that's what you're seeing here. And so to make it more apparent here, let's put away this almost 5-month time lapse and show you guys this last 24 hours automatic from the USGS view. So this is the last 24 hours here, and I mentioned it's almost 5 months, but that means it's also been 21 weeks and 149 days here. And you can see quite a difference from that early on view, which had that whole crater all the way filled with lava. And it still has lava inside underneath the crust, and that crust is thickening fairly slowly from the top down and probably from the sides in. It's still liquid in the middle. Right? In this daytime view, you hardly see any red. Just in the nighttime view, these two little ponds right here and here that are still having overturning of their crust through this foundering process that the USGS describes in their updates here. So by their mapping, most recent mapping now, they're saying over 99% was covered. That was before it even contracted even further to what you guys see right here. Hard to zoom it in any more than that. So that's the last day. So what I'd like to do is show you guys, take just the nighttime views here, and starting way back with a big picture, what it looked like back in January, coming forward. And I've just tinted the nighttime views of this is the KW camera, USGS-HVO web camera. The nighttime views usually just look like a white, and I've just tinted them to make them look a little better here, but it actually shows a lot more resolution. So it's not a perfect time lapse, right? It jumps. It's only the nighttime hours. You get the pattern there of how we decrease from that whole extent down to just those small little areas. What you might see as apparent is that the entry point is still visible here through the end of April. But come about the 10th of May, that actual flow that is pretty evident from this west to the east towards the island now is no longer apparent. We then switch to having these two small ponds. It starts off with a few overflow bursts from the ponds to the sides, right? So I'm going to backing it up here and slowing it down more and more. And so there is some of those overflows coming down to the side, and it's a little jerky between successive days because of the gap of the nighttime images. And so you really can see now that's that overturning process happening, and that's slightly more northern and slightly more southern. And this one is the one that was higher in an upper perched pond, and this lower one was part of that spillover path that came back over towards the South Island and also off in this direction. So let me back it up a little more so you can remember what that looked like here. That part of that one again. So we still had that flow going that way, and then we isolate into just those two little spots right in there. All right, so that's the view from the KW camera, the visible view actually, and so we do have the thermal view, and so I've done a similar compilation with the thermal camera, the F1 thermal camera, also from the USGS. I have zoomed it in here quite a bit, and the scale, I'm just assuming it to be relatively stationary for the purposes of this time lapse here, illustrating what we're going to see. So it's left off as well. But back to the beginning of May, this is 18 days ago. You can see that flow here from underneath the west vent. You still see a couple of glowing holes up here. And we started forming an upper perched pond and a lower pond to the side, and then eventually one over here by this seemingly dive point underneath this remaining big island that was floating around early on in the eruption. And essentially, starting from the bottom, this patch crusts over, Then this one crusts over mostly, and then up here we have a big chunk of it crusts over as well. And we do preserve some of these pathways for some time, but eventually they also all the way crust over, and essentially we have some flow beneath the crust that's moving in some unknown pattern, right? And you can still see some overflows. It appears lava is still coming in. You see some overflows still happening right around in there. But at some point that stops happening and you just start seeing it overturning, and we'll look at the elevation data, the depth data of the lava lake, and we'll see that it really flattens off and then starts very slowly dropping, in fact, very marginally, possibly just contracting from degassing, as we've seen happen throughout the whole eruption whenever we have any dip in the effusion level, how much lava is coming out. So here it is, sped up a little bit more, that whole crusting over sequence of the last almost 3 weeks here, 2.5 weeks, with the overflows, a couple little pulses, and then the most recent period here. And just overturning smaller and smaller area. So I'm going to play through one more time just for the comparison of even when it was reducing coming in from this northeast and southwest basin, it seemed like it wasn't that much. It was still a lot more than what we're seeing here. So really is most of the way crusted over now. So since I keep talking about that data, let's keep moving through the images here. Like I said, I'll talk more about the data here in the second half of the broadcast, but this is the most recent F1 image. You can see in the still image, we just still see a little bit more red, orange colors, a more recent overturning event, foundering process over here. But that's still possibly happening over here as well. But you see, really not very convincing. You really have to go to this 24-hour animation. You see that there is still changes happening. Not even on the entire southern pond still, but just on its southern margin. So that seems likely to crust over at some point in the near future. And not even in this entire western pond either, but only in its western edge now. Really closed off from what it was even a few days ago up here. Everything is closing up, so to speak. And that's the question of what will come next, right? And it really seems like the gas values that are being reported are also going down, which means we believe there's less lava coming out of the volcano altogether. So this image was from the very tail end of last week here. And this is viewed from the south now, but also thermal images. You can see this western fissure area over here and the inlet, right? The inlet was very apparent where the lava was coming into this area, into this elevated lava pond, right? Perched pond above the surrounding crust that's formed through all the various retreating and all the various little micro chapters of this crusting over story of Kilauea Summit Lava Lake. So you can see, especially starting at that southwest bay in mid-April, it was crusting over. And the same thing happened on the northeast bay that's not really pictured over here. And by a week ago, May 10th, you can see that much larger crusted over area in the southwest that's actually sagged downwards. You see more crust over here. And you also see this elevated upper pond over here, and I had this overflow pathway to this lower pond, which also came through here. It's starting to crust over through there, but also through this direction over here. So and when we look at the elevation data, we'll see that it actually jumps up, and that's a result of this levee being formed and not allowing the lava within it to build up slightly higher, just by small increments. But whatever pathway exists, it's all beneath there, and we really can't see anymore what's going on. We really can't see the effect of the surface flow, the patterns of the ripples of where lava is coming in. So it doesn't mean lava is not coming in. We just can't see it at all in the patterns of the surface. And the lake is no longer rising as well. So if it's coming in, it may be coming in at a slow enough rate that the contraction is outpacing it. So that's the unknown still. Right, the gas values are back to background levels similar to what you'd see when there was an eruption happening.
We have a $10 super chat from Langer on YouTube. No comment. Appreciate it. Thank you.
Hello. All right, so look, focusing on these views from the south here, this is that thermal view that's only released once in a while. There's no web camera from the angle. But there are other images released. Here's a summit overflight image of that same area on May 13th. And let me get it in here closer. And there is a 2 little ponds. You can see a little bit of red right in there. That's that smoother surface that's not all the way solidified and is still being resurfaced and turning over through that foundering process right through there. And that's already smaller than that area we had just last week was about that big. That's that western one, and maybe right through here, maybe this is still, you see a little bit still of this flow lines of maybe there's an entry point still coming in, and you see that flow still going, but it's not very convincing. Maybe right through there. Back. And if we move it down to this more southerly pond, this little crescent right here, it maybe is showing some flow as well. It's all just near the surface, a little bit. It's almost like an overflow along the surface that came in here, and that's showing some white flows over here on this part of it. And so maybe just the southern margin is the flat part that's still overturning right through there. So it's not as impressive as it was at one point for sure. This older well, it's older now. We're just talking a matter of days, right? This flatter patch here at the southern margin of this, western margin of the island. Island's down over here, and this is that lava lake, and that lava was flowing down into this area, dipping beneath this big island right around here. So this flattish patch, you can still looks pretty flattish, but it is all the way crusted over. You might see some glow from some of these areas and some of the cameras and some of the angles, but overall not overturning anymore, has thickened beyond that process right through there. And I just wanted to remind that during the Kīlauea eruption, after the fountains were done, and it was a much more dynamic jetting eruption of lava at that point. Once the eruption was actually over and the earthquakes were measuring magma movement away from the summit towards the Agapoho area, which was the second part of that eruption. That's beyond the scope of what I'm sharing here. The lava lake at Kīlauea was overturning for on the order of 9 or 10 days after the eruption was over, and that was just due to the fact that there was all that remnant heat trapped within it. And it was a lot different than this because it was a lot shorter, so we didn't have a piece of the crust form incrementally. It kind of all went at one time, 9 or 10 days. I mean, it kind of worked from one end to the other, but it essentially was all part of that same one-time process. It wasn't like in January, about 1 month, after the eruption began, that we started having crusting over the big eastern portion of our own Kilauea 2021 summit lava lake. Right, so a little bit different there. All right. Still, begs the question of how long can that go on, and without lava coming in, and what could be convincing proof that lava still is coming in. So nighttime views from that S1 camera, which is the camera we do have from the west, and once again starting in May. The west vent over here, and that flow goes in this direction over here. That upper pond sits back here, and a little one over here. I'll zoom it in a little more. So you see somewhat of a pulsing effect. That natural pulsing is something we've seen in eruptions time and time again. It's a natural buildup of gas and release of gas. It was pulsing from Ahuela'au in 2018, different than the surges. There was pulsing at Pu'o'o through gas pistoning events that were documented. And, no surprise, there's pistoning events happening here as well. And so you see not only the gas build up and release process from the whole vent as a whole, but also from this crust that's forming in these 2 remaining little ponds here. There's a bit of glow from that lower piece of crust next to the island right in there. And that's the nighttime view. I'm going to play you guys a daytime view so you can have some idea of what this might look like visually here. And if we could manipulate time here and speed it up like these time lapses allow us to do. There's that entry point right over here. And lava coming out through some pathway like that out of the ground, and then filling this area flowing across through here and then diving beneath the crust. And so that's what we've seen really most of the last month here, most of the month of May, a little bit in the end of April still too. You see here this perched pond, lower crusted over area, and now we're just down to there and there. Two intermittently overturning lava ponds. Yeah, so depending on when you actually look, there may not be any red lava to see. You don't happen to catch one of them overturning. But if you wait long enough, it's still happening. You are still able to see one of them or the other one overturning. A recent view here from the S1 camera from the south. And correspondingly, most recent webcam view, S1 camera live here for you guys today. So it still looks quite the same. Keep going. I wanted to bring up this image. This is from a question that came up last week about this new B1 camera, which is looking at this whole lava surface from the east side, right? And we just superimposed images from last week, so the lava surface area is still larger than it is today. But the question was about this glowing spot over here, and so there is this glowing spot in the north that has been apparent on the nighttime views of the B1 camera. And so there may be glowing spots that appear possibly elsewhere around the crater edge as well, and possibly around this lake as well. So one of the questions we'll have is, what do the monitoring signals tell us about whether the volcano is possibly pressurizing? Could it burst a small brief flare up as the lava continues adjusting to this new way of trying to get out or build up, and what's actually holding it in? So something we'll look at here a little bit later. So, but not uncommon to just have passively glowing red areas, right? As everything is cooling and contracting, you can imagine there can be some cracks and movement of the whole surface with all different kinds of topography on it. And that could allow gas venting and glowing holes and that kind of thing. And this whole, what appears to be the end game of this eruption that began in the end of 2020 here.
We have a $20 super chat from David Reed, who says, having YouTube issues in Pennsylvania. Don't know if this is live. Am I live? Enjoy your channel. Thank you, David. Really appreciate it. Yes, we are currently live. We are aware that there is issues. We tried to delay the stream. It looked decent enough to go live with. Hopefully everything is getting resolved and, can get back to normal operations. But appreciate the support.
Mahalo, Dave. Appreciate that. So here is our most recent live view of the B1 camera. And you can see that mostly crusted over, now 99%. 99% plus. Just a couple of little ponds right in there. That's the little area of active lava there and there. Pretty hard to see in there. There and there. Right, so we're just reminding us how much of that crust is actually solidified. And so along those lines, there are new maps released by the USGS-HVO as well, who is a source of all this data, just to reiterate. And so now, May 13th, the blue colors are the cooled areas. The orange is the hottest area. This yellow is area that's still in between, right? So these areas are maybe not freshly overturned with hotter lava, but maybe just did that within the last few hours or so. So you see the active area much smaller over here. And to put that in context, they also released a second image sequence here. And so here's May 13th, the image I just showed you guys. It's in the bottom right over here. Let me zoom in a little bit and get it on the screen a little better here for you. So December 21st up here in the top left. And we still had the North Fissure and West Fissures both. The island already had formed from that, we believe, interaction of that first lava with that lake of water that had filled Halemaumau crater in a previous little bit over a year. And you can see very quickly it rose up and drowned that north vent, rearranged. The west vent became the primary one. You can see its elevation right around in there. Right, and as you can see that as the lava came up, it's gotten closer and closer, but that vent has rearranged, even as in mid-January, that eastern crust really was the biggest first biggest crusting event, right, when the whole eastern half went at once. Everything that was east of that island, right? It seemed like the one island was oriented lengthwise up here on December 30th, that we still had a pretty good circulation of flow around there. And then somehow when that thing turned at mid-January, that area behind it was almost in its shadow and became more stagnant. At least that's how it appeared. And from that point on, there was still lava that went around the island to either side, surrounded it entirely, as late as February here. But by March, those arms had withdrawn back to the west over here, and then we lose the extensions that are north and south of the island. So we have our more oval-shaped west vent perched lava pond right there, and we can see that we've just dropped off considerably most of that surface, and essentially we're all but crusted over here. So we'll see, by this time next week, we'll have a clearer answer of whether the lava is really coming in, or if the crusting over, the foundering process that can be ongoing for days after the eruption is over, continues, perhaps from the buildup of what ended up being 11 billion gallons of lava so far that's filled that crater. So it could overturn for a while longer and different time length than Kilauea as well. So we'll see. All right, so there are some other views. This is an aerial view here from May 12th. Well, actually, this one's not an aerial view, not yet. That's the next day. But so above the west vent here, there's the upper west vent with the gas plume still emitting. And so even though the gas value is being measured or still at background levels, you can still see the gas coming out around this whole west vent complex right through here. And although you imagine there's a lot less fog around the island because of that, it is still coming out, and coming out at detectable levels for sure. Right, so lots of topography here on this backside. I'm not going to go through all the details of frozen crust today and on the crater wall, right? But we're going to view here is from the west. I'll draw a north arrow. North is going that way here. That's a view from May 12th, and another view from May 12th. You can see a lot of these. You don't see so much of the red, but there's that upper pond and lower pond. And that lowest crusted over area, and by that big island. This is the big island here. You see a little better. Right up there. Big island that is pointing out on the thermal images, and still visible as this very high pile of cinder, right, with all these lava benches that are lava terraces that are preserved on its edge from all the successive changes of lava levels. And so a few more pictures here. There was an overflight on May 13th that actually generated those thermal images and that mapping and that statistic. So some of these views from a little bit higher angle. There's north is now this way. Here's our west vent. There's our two little ponds. Crusted surface. You can really see a lot of the different colors and topography. It's really interesting to think about. These are big features. If you were able to be down there walking around, it would all be like hills above you. Right? Really, really interesting topography that's resulted here. Speckled on one side over here. A big high lump in the middle, and then successive terraces that feed back to, it almost looks like little islets here, little loci, and a couple of lava ponds over here. This vent here down to the side, so interesting features here. All right, west vent over here. North is back that way. Here's the edge of that pond, edge of the terrace, and a little bit closer view at these two ponds. There it is, daytime view. Maybe see a little bit of a hint of it being freshly oozing out right through there, but so slow you don't really see the red. and don't really see much action over here in the backside of this other lower pond. And keep going. Closer view at the west vent itself, so you can see there is the gas coming out. Still bluish, maybe in some areas looking a little bit more whitish. That's something that people have been commenting on in the past, and if you read the old historical accounts, one thing they're looking for is to see if the gas starts changing colors back to something more just like a steam rather than being as much volcanic, but the gas still seems to be coming out. So that would lead you to believe that the lava would still be coming out as well. That's the interesting dynamic there, is that we're trying to balance and sort out what's going on. If it is coming out, it's coming out pretty slow. So gas is being measured there, and they've also released another aerial photograph. If you've ever been to the Hawaii Volcanoes National Park and walked on a Silver Banks Trail, it has a boardwalk. That's this area right through here. Visitor center is over off in that direction, over there. So boardwalk coming that goes towards the steam bluffs off for that direction there. So this is the actual outer caldera wall of Kilauea, and it's a place where deeper magmatic gas often escapes, and it's a place that HVO also samples. So cool to see an aerial view of that area as well. But back to the lava lake. So as I said, depending on when you actually go and capture your image, you may not see a whole lot of red, but sometimes you will see the whole surface overturning, and that's photographed here on May 14th, I believe. So just the upper pond, you see independently the pieces of the old crust being consumed here as fresher lava from below. That's presumably a little bit more gas rich. It's more buoyant, breaks through the cracks, and this slightly colder and harder stuff then is able to essentially sink back into the lava and get replaced with liquid lava, which then quickly cools and makes a new crust. And you just repeat over and over and over until at some point you don't have enough gas to break through that crust, and it solidifies all the way across. And so that's what we have not seen yet in these two remaining little ponds. And another view, May 13th. This time, it's the southern pond overturning here. See a similar process, the big slabs of crust. Whereas that same northern pond appears completely dark in color, right? Same thing, lava is still building pressure underneath there, and it'll replace all this crust, as we have seen through our earlier time lapses. What it would look like if you could see it in person there. One more May 13th, capturing both at the same time. Well, not exactly both, because this patch over here is that in-between patch that started glowing. You can see a little bit of it looks like a lava flow oozing out from right there. So it seems a lot like this is still connected to this lava pond. And maybe the lava is able to leak out and ooze out through there a little bit. Still evolving details of the topography, especially around this pond area. All kinds of terracing and cracking, and there's some terraforming happening for sure on a daily basis over here. And the most recent image we have with the red is May 17th here. And you can see here there's that upper western pond and that lower pond. So it's the lower pond once again from a different angle. North is back this way. There's our big island edge once again. So, right, and then one final view, daytime view here. What it might typically look like. You might see a little bit of lava starting to ooze up through the cracks in that forming crust, and that's the signs that the overturning pulse is coming at some point soon. You have enough pressure, and this stuff as it cools wants to sink down, so it's containing any lava or gas or adjustment of the liquid underneath it as well. So that's why that keeps happening there. Scroll it down here. Go to the lower pond here. This flatter area right through there is the one that's probably overturned as well. It seems like there's some pathway that at one point left these Pahoehoe rings that came in from this upper pond, this lower southern pond right through there. All right, and that's all the imagery that we have to catch up on for the last week here on the summit of Kilauea, which officially is still erupting. And we'll see if once the crust overturning is done, if it stops or if we'll have a sustained smaller open pond. We'll have to wait and see. Once we say our thank yous here and discuss some of our live viewer questions, we'll turn to some of the monitoring data and address those issues and those questions and see what we can learn from that.
All right. Well, thank you for the presentation. I do want to thank Hawaii Tracker for helping make this possible. We go live on Hawaii Tracker on Facebook, YouTube, and Twitter. If you support this type of content, best thing you can do is like, subscribe, share it. That really does help the channel. Also consider becoming a member on hawaiitracker.com. That's where we post all of our updates and write-ups, and basically it's a chronological collection of everything you need on the volcanoes. And if you want to make a monetary donation, if you are so kind to do so, we take those on hawaiitracker.com/support or super chats on YouTube. We do have a couple sponsors I want to thank. First one is Kīlauea's Bar and Grill in the heart of Pahoa. Kīlauea's is a fine dining establishment that is on the affordable end of the price scale. Everything's kind of weird with the economy, but a great place to drop in, either visit for visitors or for locals. Got indoor, outdoor dining options, full bar, unique local takes on some classic dishes. The prime rib there is insane. The fish and chips is always good. So if you're in town in Pahoa, check them out. Second is Kailani Tours. Kailani Tours does some very intimate tours compared to the big tour bus kind. These tours are more educational and help familiarize people that are not from the area with some of the more local knowledge and the reasons for the caretaking that is done by many people. Just kind of help give you that local feel, a little more personalized tour. They do coffee tours, they do volcano tours, and waterfalls. So check them out. We appreciate their support as always. With that, let's get into some questions, huh?
All right.
Now, it doesn't look like we have that many questions. I'll keep an eye on the chat to see if anything new comes across. But Robert Hill asks, has anyone successfully modeled lava flows and the associated features that develop?
Yeah, so there is quite a lot of work has been done, and there's models on a larger scale stuff like the path of lava flows, which is something that's more relevant during eruptions towards populated areas. But there's also a lot of the smaller scale modeling that's been done for when you have a change of slope and you have lava that's going from faster to slower, and that's when you start forming your surface features like wrinkles and coils and those kind of things on the lava flows. With their pahoehoe, or if you have a'a flows, like the size of channels or how they advance, all that stuff's all been modeled, but not all at the same time. There's not one model that puts it all together as far as I know. There's a lab in upstate New York that actually makes their own lava and pours it out and looks at the shapes and changes the angles and all that and tries to model flows that way. So there's all kinds of interesting stuff that's been done. So yeah, interesting to think about that, and at some point we maybe can go into more detail. So yeah, great question, Charles.
Right.
Thank you.
Next one is from Beth. Asked, do do volcanoes on Hawaii Island produce different kinds of lava, different chemical compositions? Or are they all the same since they come from the same hotspot?
Yeah, that's a great question. I mean, it's all about how picky you want to be with the details, really, right? Because when it comes down to the detail, everything is uniquely different, right? And so when it comes down to it, you make generalities and say, yeah, that a lot of the rock that comes out from hotspot volcanoes on ocean plates, for example, is a similar kind of basalt. and that's generally similar to the lava that comes out from mid-ocean ridges, those underwater line of volcanoes where the tectonic plates come apart and spread apart. There are also basalts, but you could pick and divide them, right? Between them, and they're different than other volcanic rocks, like ones you might have at St. Helens or Pinatubo or Yellowstone, which might be more evolved with higher silica content of the lavas that could create different kinds of eruptions, right? But sticking with the Hawaiian stuff only the Big Island volcanoes, the hotspot does generate magma at the base of the crust there. But the pathways from the hotspot through the crust to each volcano are separate enough that there are distinct, detectable chemical differences between each kind of magma. So each magma has its own, as we call it, a chemical fingerprint. And that can differentiate every volcano in the world, in fact, because of those. Our detection capacity is pretty good compared to the variations that these things show worldwide. So yeah, they are overall basically the same, but there are definitely differences and important differences, and then the scientists are picking and researching at all those little differences to try to synthesize volcanoes like Kilauea and Mauna Loa together and back to the hotspot, and what it might be doing long term, and all those bigger picture questions that are really interesting to get at. Yeah, so we'll certainly report that as we see it come across the wire, all the new research that's along those lines. Yeah, but that's the basics of it. There is that they all do have their own unique fingerprints, but they are, from a layman's point of view, mostly the same thing. Yeah, especially the Hawaiian ones, and Hawaii to other hotspots, and then
Right.
Hawaii to mid-ocean ridges mostly, and then less so Hawaii to other volcanoes in the world. That's where the big differences come in.
Barbara on YouTube asks about the comparison that we did previously, where we dropped a 747 in the caldera for a size comparison. Now we haven't done that again for this, but how do you think it would, relate if we were to drop in that size comparison, like a plane or the Empire State Building again?
Right. So the distance between, let's see if I can pull something up here that shows it. Shows it a little better if one of these images is going to show it. All right. So one of the images that we just showed here. They've said before that this distance from this west event area to the edge of the island over here hasn't really changed. I forget what it is exactly, right? But we lined it up. That was essentially 2 planes worth. 1 plane, 2 plane. That was more or less the size of it, like that. And so this paw now is getting to be, maybe half to a third the length of a plane. Might be the closest ballpark guess without having prepared it that I could give you guys, without giving you guys actual real numbers.
All right. Jennifer on YouTube asks about obsidian. How is it formed, and is there any here on the island?
Okay, so obsidian, generally speaking, is a volcanic glass that you really don't often see crystals. Sometimes you do see pieces of pumice in it. And that's kind of a giveaway of one of the differences between the volcanic glass that's called obsidian, which is that it forms during eruptions that also produce pumice. Right? So usually that comes from stratovolcanoes. You have that really hot ash being blown in the air and all landing together in big, thick piles. And when it's landing in big, thick piles, it can actually fuse itself together and form that black glass that's quite often used by Native Americans for arrowheads and that kind of thing, right? Flints and that's I forgot where I was gonna take that next.
That'll happen. So what about like the silica content of the thing compared to what we have seen on the islands? Like
right. So yeah, exactly. Yeah. Typically speaking, that kind of eruption is not what we see here in Hawaii. So we have lavas that are more primitive, as they're called. Essentially, they're closer to the average of what's inside of the earth. And that means they don't usually form the kind of eruptions and don't have that higher silica content that's typical of obsidian there. Right. However, the volcanoes do go through a whole process and a whole evolution of their magmas, and different magma pockets, especially, can go their own separate evolution from the whole volcano. So, for example, north of Mauna Loa, and you can see by Hualalai there, there's a big flow of very silica-rich trachyte lava that I think I've heard not quite obsidian values, but getting pretty close to volcanic glass content of silica rich, that you might have a volcanic glass close to obsidian in some areas in the upper hills there in Upper Kona. And that's, for people who are living here in Hawaii Island, that's something that's not unheard of, is finding flakes of quote unquote obsidian up in that area, like Walleye Country Club, for example, area.
Right.
But overall, most of the volcanic glass you see on Kilauea, for example, is just the really quick cooling outer rind of lava flows themselves that's forming a glassy surface. And that's just a textural thing rather than a compositional stuff. The chemistry of that would be different from the obsidian. Just kind of hard to explain there, but that's the nuts and bolts of it. Thanks, Dane.
We have one more question here. This is a common one we get, but it still applies. Is it possible the magma may find another easier way to the surface rather than just stop flowing into the lake?
Yeah, that's a great question. Absolutely. And if you think in long term enough, then guaranteed it's going to find its way to the surface somewhere else through some process that's happening deep underground, whether or not we see the effects of it in the surface today yet or not. Right. So it's just a matter of time, no matter what. We may be seeing effects of buildup of magma within the volcano separate, right? It seems like the volcano has been still slowly swelling ever since really January, right? It was only about a week of eruption that it wasn't. And that's common, that when eruptions are over, that the volcano starts swelling again immediately. So if we got most of the work done early on in the first week, and essentially we've been mostly coasting from there, then that could be the that could be where we're headed here. So we'll look at the signals here and figure out if there is any indication of pressure building, for example. Like the tilt might be coming up a little bit. It's not coming up alarmingly, but it's going up because lava can't get out. Then we'll know that pressure is building, and maybe it could burst out a new part of the west vent. Or maybe it could burst out a new piece of the fissure nearby and start flowing, or it could crack open the crust over the lava and flow out onto the crust from some vent on the surface itself. Right, it could actually erupt like a little spatter cone on that new floor of Halemaumau at some point. Right, and if you have earthquakes or movements, that gooey liquid lava that's within it already may deform in a way that you might actually crack it and have small eruptions coming up from that as well, right? And also imagine gas building up over time, building up bigger bubbles, building more pressure, and so there could be some funky things that happen, and we'll have to really keep a close eye to tell, like, oh, here's a new vent possibly opening up, or this thing is actually just cracking and venting and glowing for a short time before it actually peters back out, right? It's not uncommon, as we saw in 2018, for the eruptions to have like one final reactivation and one last release of gas, almost like a burp, if you will, right? One last burp that comes out and spits out a little bit more lava or deforms things a little bit more. So that is possible. That's really the big question, is how long is it going to be until we see another big vent open up? And well, we're building towards it. It's just a matter of time. No signs of anything really imminent that I can tell is obvious to me. Right? And we'll go through the signals here maybe now, Dane, and talk about the details of that, and everyone can come to their own conclusions of what might be coming next. Right? We can do one more round of questions here at the end.
Yep. We do have one last question from a $5 super chat. Oh my God. Theo Prastius, I butchered that, I guarantee. Does magma make its way to the surface by melting channels, a hot knife through butter, or by pressure splitting apart the rocks and filling in the cracks, or both?
It's gonna find the easiest way up. So I suppose if there's really no other pathway up and it has to melt its way through something, and long term when you have millions and millions of years, that's generally the process of how you start off a hotspot, for example. But most of the time, it's trying to find the easiest way out. So what ends up happening is as volcanoes pile up on its surface, they end up pulling away and creating rift zones that are essentially fault lines. And so you have cracks that already exist from the gravitational settling and spreading of the volcano. And then the magma makes use of those as pathways. And it doesn't actually have to melt through from scratch. It can melt through just the edges of that thing. And over time, the pathways that stay in use end up getting reshaped and opening, and the areas that are used less often end up solidifying and freezing, if you will, and plugging up and having to be re-injected and rebroken, which is why you see sequences of earthquakes that lead to magma moving from one area to the other through these old pathways that are kind of clogged up already, right? So that's the ins and outs of that. Yeah, so it can melt through, it can crack the rock, but most of the time it's going to go and wedge itself into a crack that's already there and then try to push it apart. It's forced to push apart, and that's what will cause the earthquakes, more likely than not.
All right, well, that'll do it, and we'll do one more round of questioning at the end, yeah?
Sounds great, yeah.
All right.
So yeah, I was kind of teasing the depth as being one of the more interesting things that we're looking at here. So let me show you guys this plot going back to the beginning of the eruption here. So at the left edge here in green was the depth as it came up quickly in that first week, right there, and then still rising fairly quickly, but it's really at lower and lower rates. And finally, here we come to the end, and we had a couple steps that have increased the level all the way up to 229 meters, 700 and what is it? 745, 748 feet. Yeah, and that's what it looks like on a big scale here. Let's zoom into the week. So here is over the last week here on the bottom, last week. And so we're ranging from 228.8 to 229.4. This is only a half meter variation. So we're seeing we had some small variations, and we had one jump here. This is probably that ponding and the perched pond and being able to fill a little bit higher. But right here, this is the peak right here, 229.3 meters that we've seen. And so you do see this is likely that foundering process, right, with some cyclicity here, right? But in overall upper bounds, that seems to be in a very, very, very slow decline, right? To the point where maybe we're at 229.28 or something, down from 229.32 or something like that, right? It's really not a whole lot. It's generally fairly flat, but it's definitely not rising anymore. Right? That's the obvious thing here. And to zoom out to the last month and look at this change a little bit more, where it's a little bit more obvious, you can see here about a month ago, we're still having quite a lot of that variation, small scale variation, larger variation. You know, we imagine that there was some version of overturning and crusting over near the entry point of the vent, as well as pistoning at various orders of magnitude within that lava lake. Right? So all that kind of background, it's not exactly noise, but all that background process that's registering on here on this line earlier on, you can see by right around in here, and it changes in character, and it becomes more of that steady. It actually started having that pattern of steady down, right, with an intermittent foundering, which has a different signature than this active moving lava surface, right, where we have coils moving past and the vents bulging and having its own pulsing nature from the actual entry point. So from the signal here, you don't really see any of that past this point right in here, right? That falls somewhere around, hard to tell exactly, the 6th perhaps of May, right? So that's already 12 days ago. But because we did see this stepping up once, twice, 3 times here, it's not been obvious that the lava has ceased coming in, right? It can still be coming in and causing the pressure upwards to form the upper levee and raise it up and raise it up and raise it up again. And so we'll see here, right? We've gone on for a while now. It's been 5 days of this ongoing since the last time we had any of these overflows from the ponds. It's been over a month since we had any of the ooze flows from the edge of the crater. And so this is the signal right here. This is the most obvious. I can show you guys right there. The clear difference in nature of the pattern here on this side. Actually, all the way to here. You know, all this stuff, right? What was happening beforehand. So that's where the question really comes in. Is the nature of lava coming into the lake actually different as well? And hard to tell just from that right there. So looking at the tilt data, this is the past month. You can see we still have small deflation inflation events. I say small because we are ranging from, this is +2.5 to -2, 4 microradians or so, not as big as some of the ones we had earlier in the month. And we're in the range of 6 microradians or so. So a couple of those, they haven't been happening as frequently as they were happening last week, right? And getting a little bit bigger as well. But more recently, we haven't had as many, and we have been on a slow rise here. Right? I say slow because you can see some of these other times during deflation inflations, that's what a fast rise looks like. So it is rising. It's different. It's kind of an interesting, weird little signal. It's not alarming or anything like that. We can zoom in here for the past week and see one of the most recent small deflation inflation event from, looks like maybe 3 microradians more or less or so, 3 plus. The last 2 days here, we went down from -0.5 to +1, so it's really 1.5 microradians that we're seeing here over the last day and a half is what's showing as this little rise right in here, right? So it's not alarming. 1.5 microradians, it's not that much really when we've seen much larger swings. So to kind of try to answer the question of do we see any signs of any new vent opening up, that's what you would imagine you'd see a much steeper. If this thing starts skyrocketing up like that, then maybe we'll say, okay, something's got to crack open for the pressure to get relieved. So as it is, it's still kind of curious what exactly is happening there. And look in detail on a most zoom in you can get. It's actually been going down a little bit. I suppose I can try to reload it here and see what it looks like. Yeah, so there, it's actually come down a little bit and stayed down a little bit since then. So it doesn't seem to be a runaway process, whatever's going on. It's just still adjusting. And likely adjusting to the larger amounts of crust, right? And maybe set a new baseline there. So nothing really alarming there. It's interesting to know what's happening. And the gas values have stayed low despite the tilt showing these little variations through here. That's the other sign that supports less lava coming out, and then no sign of any bursting coming forward, yeah, in the short term. All right, so we'll keep going and look at the GPS here. So we can look here, look at the summit line across north and south across the summit. And it is still slow rising here. We do have these adjustments from deflation inflation events, and we'll have to see what happens here. It's hard to really judge the most recent period from this 2-year-long plot. 2 years back and forth that way. So we are still rising faster. It seemed like we had a flat era in here, but it seems like now we're more of a spreading, and not as fast as through here, and certainly not as fast as before the eruption through here, but still spreading. And the overall pattern after that first week of spreading, building towards the next eruption, wherever that may be. And so not a whole lot of change there. Last 5 years, in comparison, these are all small changes in 2020 compared to what happened in 2018 with a major summit collapse. We'll be looking at that for years to come still. Moving down the rift zone, there's some interesting bait over here, actually. So we're looking at the distance across the east rift zone from NPOC to Jacuzzi. This is that signal. This is the 1-year plot. So you see it's spreading as magma is pressurizing not just the summit, but the upper east rift zone of Kilauea as well, where it reaches some capacity, and eruption happens in December, and then you can see that pressure being relieved coming downwards, and that's been the overall trend, right? With more relief, then more stable, and possibly more relief here in the most recent era. So if we start looking closely in here, it looks like there's a trend. This is what I call a data bait right here, right? Where it's a very appealingly trend where it looks like this thing might be shooting back up, straight back up here. But this is where I have to issue some caution. It's not quite clear that this is a real trend per se like that. It's pretty rare the data lines up that well. There's almost always some noise, even when it is fairly coherent. Rising eras like this, right? So it's can happen sometimes, but it may still be the noise and the adjustment, right? You still see there's a lot of this kind of thing that can happen in the data as well, where you get a lot of scatter back and forth, and we have seen quite a bit more scatter in this more recent part of the year here over in the East Rift Zone. So still curious to, might lead us to investigate a little further. It is still an overall downward trend, and we'll see how this plot updates here in the future. But at first glance, looking into it, didn't really see much cause for alarm. We can show you guys. Here's an NPOC station. You can see the east has certainly stabilized. Right, this is leading up to the eruption, right in here. You can see how before the eruption looked like and how it looks now. Different on the east. Right? Before the eruption on the north, and now, maybe similar, kind of flat. Before the eruption, right? Leading up to it and flattish, and now we're coming down and flattish. So the up, none of the signals really looks the same, and so you are seeing some changes in direction and likely some still local adjustment happening around Pu'u'o, as we have seen reports of that. Collapse is still ongoing there. This is the other station in the south that they're measuring against, the Jacuzzi station. So it's also showing, you can see before the eruption, it was moving to the east fairly rapidly, and you may see a little bit of that here on the east. If we look in the north, we're actually moving a little bit back. That's not quite clear here, maybe not quite clear what's happening here as well, but maybe most importantly, as we look at the up, we've been building up to and flat. And similarly, the Jacuzzi has been going down, and in fact, it's not even flat. It's still going down over here. So whatever change is happening, it's possibly localized, and it's more complex than just looking at that graph and seeing what looks like a plot of lines going up and assuming something is happening by Pu'u'o. So just a warning on that in case that comes up anywhere. And still more data needs to come in for us to see what's going on there. Of course, doesn't hurt to scroll down and look at the Jonica station further down the rift, and no major changes happening there as well. Seems like that patterns are still slowly down, slowly moving south, consistent with south flank, and stable on the east, right? And if you zoom in, maybe some little wiggles, but once again, that's within this range of the wiggles that it normally does, and nothing to be alarmed about there. Part of the earth moving. It won't do any more GPS than that. We'll move on. Show you guys earthquakes and see what the earthquakes are supporting as far as changes in the volcano. This is the past week here. So there is movement. There is some adjustment happening. Minor background levels in the summit area right through here. A little bit in that Kauiki area bordering Mauna Loa. So that's kind of independent. This is this whole zone over here. Right, so interesting to see that there is adjustments around the summit, not unexpected because there are changes happening at the eruption at the summit. So you'd imagine that there's going to be some change. The earthquakes may go back up to a higher background as they normally are, because it's really been atypically low during the eruption. You see a couple in the upper East Rift here, really not a whole lot. Mostly you see south of the East Rift over here on the south flank movement still being something that's happening. This whole area moving to the south. That's what opens the rift zone, essentially, and allows opening of the summit area, and magma injects through those cracks and pathways that exist through there. And then the southwest rift over here as well, not showing as much here in the last week map, right? But if I let's just show you guys this plot first, and then I'll jump to the last month. But we often look at this plot, or often you guys look at this. It's more easily to find online for non-Kilauea Hawaii volcano followers. So all this is normal background. I won't go into that again today, but for the last week here on Kilauea, you can see the oranges are the last couple of days here, a couple under the summit, a little more closely, and South Flank. You do get a couple here in this rift area right through there, but not huge amounts. But to put it all in perspective here, this is the last month, so you can see a little bit more clearly this summit area of adjustment, the southwest rift extension, the upper east rift extension, a little bit marginally these two, right? It's not nearly the levels we saw before the eruption, when we saw distinct extensions with lots and hundreds of earthquakes in each direction, and we thought this thing is primed and ready to erupt at any point, and that was prior to this eruption, which obviously has solved that problem. And you see here mostly south of the east rift zone on the south flank. This is the area of the flank that's moving, right? Interesting, still here, right? And see, for a whole last month, not a whole lot down here. You get a couple as far as over here. He has one over here. But really, you don't get a whole lot of movement down here, this farther area of the south flank, right? It's really all kind of coming across through here, which is interesting as well. And so that's good news that you're not really seeing movement all the way through there. It does seem to be possibly adjusting. If you see adjustment, this is the Alaili area over here west of 130. That is maybe the margin of where you're still seeing some effects. Movement of south flank and the Jonica stations in there as well. And there's no evidence of any magma that's new in there, but there is still that kind of cooling pattern that happens in that area. It's somewhere when magma is moving through in the future, you certainly want to keep an eye on for sure.
We have a $6.99 CA super chat from AH Boomer. It says, "Love what you guys do. Keep it up. Would love to see a technical recap of 2018. Dane, I am enjoying your drone footage videos." Yeah, I'm doing kind of our own recap, a little bit recap from the perspective of somebody, a resident, basically, that followed the eruption closely. Technical recap, I believe USGS has some of those, right?
USGS has a whole bunch of those that we have posted on our channels. And in fact, we have even remixed them and compiled them in different ways, recapping different aspects of the technical part of it, whether it's just the gas or whether it's the earthquakes or whether it's the geology and all that. So maybe we can find some links, Dan, and post them in there. But otherwise, you can go back on our channel and this is the 3rd anniversary of 2018. As we're traumatized. We've been talking about it nonstop for a long time, and we certainly have covered a lot of that. And this time around, it's Dane's series, which is premiering a new video again tonight. Right. Is our I don't know, communion with that eruption now that's gonna live forever in our minds and in our hearts, of course.
So yeah, check it out. We have the new video will premiere immediately after the stream, and we do have those technical analysis on the channel as well. Thank you for the support.
Yeah, mahalo. All right, so sticking here at 2021, last month, earthquake rates and depths. You can see this is the normal variation. You can see the levels are essentially constant. This might be another little bit of data bait. Might think you might have a little trend here. This is really too small wiggle, right? It's within the variation we're seeing. So you see, it comes up naturally, down naturally. If we were to pick a different size bin for this rather than earthquakes per day, we might see a slightly different pattern, and that's part of the issue with these histogram kind of plots. But you kind of see, if you learn how to read them, that the background has been fairly steady. Not a whole lot of change, the order of what you can tell here. If we zoom out to the past year, it's a little more obvious what we're looking for. Earthquakes per week now. This is back in June. You can see here is a building up to the eruption, right? We actually built up to this was actually an adjustment between Kilauea and Mauna Loa that built up, right? That was our first kind of warning that the summit was adjusting radically. And then here is our build up to the actual event that erupts right through here, beginning with an intrusion, a couple-week gap of heightened activity, and then the actual eruption. And then after the eruption, we drop off. So the background, since we've been erupting, has been a lower background than we saw in the long term prior, and even elevated leading up to the eruption here. So maybe a slight upward trend here, right? But we still haven't reached anywhere near these other levels that we're seeing before. That's the takeaway here. earthquake rates for the past year. So, and really, the most important thing, perhaps saving it for last here in our data coverage, and that's SO2. The most recent SO2 measurement, 175 tons per day. That's still very, very low. You can see that in the last week here. Our highest measurement might have been somewhere around 250, a little less than that maybe. And we've been down just above 100 as our range for the last week, right? So you can see that going back to a little bit prior to that, all these values are essentially within a range of normal background without an eruption. So you could have this and not have lava coming out and be okay with it. So we do see gas coming out of the vent, and we do believe that corresponds to the lava still coming along with it. But at some point, how much is the lava moving in, or is it at some equilibrium where it's not moving in or out, right? One question that that we could it's difficult to reconstruct is what's the elevation of that lake relative to that changing vent geometry, and the elevation finally make a difference, and it's hard to tell. And the gas, the most important thing here would lead us to believe that despite everything else we're seeing, the amount of gas coming out is less, therefore the amount of lava coming out has to be less as well, and it's essentially almost indistinguishable from nothing coming out.
We have a $35 super chat from our friend Gary Bryan. He says, appreciate your straight on reporting. It gives me confidence as to how to read the USGS photo and report releases and the deeper explanations behind them. Fascinating. Thanks, guys. I appreciate it, Gary. All for your continued support.
Mahalo, Gary. That's the last month here. You can see the highest point is 600 on its tons per day. We're having some higher values up here in the first part of the month, but really I gotta zoom back out to look at the whole year here since the beginning of December. And our scale now is up to 60,000 here on the left. So early on we really spiked really high and dropped off pretty quickly. 10,000 is this first grid mark here. So really we were at 5,000, down to a few thousand, down to about 1,000. And so our average really for this whole period from mid-February to mid-April is about 800 tons per day. So now that we've been for the past 2 weeks in this range of averaging around 200 tons per day, that's or less, that's the background level right there. That's what we're really saying, how long can this continue and lava keep coming out or not, and this eruption continue as well. And so that's what we're seeing the possible end game here, unless of course it repressurizes and bursts out of the crust, or builds gas and burps out one last time, or pressurizes and builds a new vent and comes out and rejuvenates in some larger way that is more sustainable in the long term. We'll have to just wait and see. There's no answers, unfortunately, that are dead giveaways here. But these are all the patterns that we're seeing here, right? Of course, the good thing about the gases being down to this low level is, we haven't shown this in a while, but our VOG mapping project, right, from University of Hawaii, Manoa, you can see there is still some VOG being dispersed around the island, but not nearly the levels that we're seeing at some of the previous updates here. So there are times, of course, where that 200 tons per day still is flying towards the southwest and can be concentrated in some of these areas that are usually upslope of residential areas, but sometimes does affect people down here in the South Hawaii area, right through there exactly. All right, so that is the data that I do want to make sure that we emphasize. This is all coming from the USGS-HVO. This is their text update here from today. So you can see that they are saying 229 meters, 751 feet. So I got it wrong. Both my guesses were wrong. 751 feet deep, 129 meters, and stagnant over most of its surface. SO2 emission rates are elevated at 175 tons per day, last measured on May 14th. So this is a decrease. This is where the 800 tons per day is right there, minor change. They haven't changed any reporting on our East Roofstone observations. They haven't changed much in the last week, although it does say a little bit different than we are typically used to seeing. Right, so they do say effusion from the west vent continues to supply the lava lake through a submerged inlet to the lake. So they're seeing evidence from their end, at least, that they think lava is still coming in. Circulation and intermittent foundering of crust are confined to 2 small pools with rare overflows, and lava has not oozed out along the perimeter of the lake over the past week. So, skipping ahead, stagnant and solidified lava crust covered 99% of the lake surface as measured by thermal mapping on May 13th. Right, and this warning of the possible pauses or lulls or end or waxing and waning of the eruption is something we've been talking about for several weeks already now. So we'll not rehash that once again, but that is where it comes from as well. One final note of news here, and this is something you can find on hawaiitracker.com, and is an announcement by the USGS that Tina Neal, Dr. Tina Neal, who was the former scientist in charge here at the Hawaiian Volcano Observatory, is to lead the national USGS Volcano Science Center, composed of Alaska, California, Cascades, Hawaiian, and Yellowstone observatories altogether. So I'll let you go to the site and find the link and read those details there. But it's certainly we can say that we're thankful that Tina was around during a 2018 eruption to lead the USGS throughout that challenging time there. So, all right, Dane. We can have one last round of discussion of some topics here, and then we'll get out of here.
We'll do a few questions, and then we'll wrap up. So Andrew asks about the ambient levels of SO2 in the area of the summit unhealthy.
If you're sensitive to, if you're asthmatic or have some kind of sensitivity, then it could certainly be unhealthy. Everyone has a certain different tolerance. We found that to be true not just with the SO2, but also the H2S that follows after the eruptions. But for most people, it's tolerable for the length of whatever visit you have, right? And most of it blows up into the air and blows away, and we actually detect as a much smaller amount. So really, the concentrations are important because you're not going to usually experience that high level concentration unless you're approaching the event during 2018 eruption, which was really record levels of gas. But otherwise, you're really just at the periphery, and you're just getting some smaller amount of that, right? So the park does have all the safeguards in place, and they will close viewpoints if the fog gets bad enough, and they have rangers with monitors and all of that for anyone who's in the area watching. So they do a great job with that.
You can also check out HawaiiSO2Network.com. It has the National Park Service air quality health advisory levels. They have 6 levels ranging from good to hazardous inside the park, and also some points on the west side, Ka'u, and also Kona. And right now, across the board, we are showing green by their scales, which is good conditions. But those can, change with eruptive activity like we saw in 2018. And yeah, just straight green across the board right now. And also they have particulate matter sensors as well, so you can check out what's in the air besides just SO2.
That's right.
Yeah, that's some good stuff there.
Perfect. Thanks, Danny. I put up on the screen as you're talking about it there. So yeah, and here's the key at the bottom. The green being good, yellow being moderate, then by orange they say unhealthy for sensitive groups. So they do change the status and update the whole park throughout and have different response policies. So
yeah,
great question.
Boomer asks, is there a geologic reason why the west side of the Big Island is less active than the east?
I would only say that it appears to be so based on the century that we're living.
Right.
If this was big. Yeah, and if this was, it's interesting because if you go back to the era around 1800, right, we had 1790, Kilauea had its big explosion. In 1801, Hualai is erupting. In much of the early 1800s, Mauna Loa is the one that's going. And really, Kilauea has reawakened more recently in the 1950s, right, after that long era of lava lakes with kind of low total amounts of lava coming out. That was right when Jagger first arrived.
As we've said before, Mauna Loa didn't get that big by not erupting, right? Like there's a long history of eruptions there.
Yeah, and this is where there's a little bit of a disconnect between this whole geologic time and human time, right? Because I do often talk about how the volcanoes change at a human time scale, but there are other patterns that are a little bit longer that are harder for humans to grasp. So we just went through a 35-year East Rift Zone eruption, which is one of the longest on a historical record. And we believe that Kilauea and Mauna Loa play off each other to some degree. So that essentially has been holding Mauna Loa back for that era of time. So however old any of us are, if the last 35 years, or have been abnormal, then our view of it is also abnormal. Is the bottom line there. That's the tricky part about it there.
All right. Well, let's see here if I've got any more questions. Looking like we're basically done with that. We'll explain this one again. We'll do one more. We've done this one before, but has anyone gone down into the crater and taken a sample of the lava yet?
I don't believe that is the way that they're sampling lava. That since there's been typically so much gas shooting out of there, you normally pick up the droplets of spatter, or Pele's hairs, or Pele's tears that fall downwind of it, and you essentially do the lazy man's collecting rather than trying to get down that crater wall.
Right. People have in their mind some like Mission Impossible sequence to get down there, but in reality, it's just more like walking around the side of it and picking something off the ground, or going to the net that you set up to catch the stuff earlier and pulling it out of there.
Yeah, you like to have, normally it's like a 1 meter surface area box that you'd have, and you'd elevate it 1 meter off the ground. Make sure you don't have anything from the wind on the ground blowing stuff from the ground in it, and you want to make sure that it falls in, below the plumes. So you want to be kind of in the right place where that's happening. The winds can change, that can mess you up. You also got to go out and empty it every single day, so that you know that whatever fell there is from the last 24 hours, and that's how you can tell which stuff's from when. And so a lot of that has traditionally been done. I'm not sure how much of that's ongoing, but I'd be surprised if there isn't habitual collection and tagging of samples that they're cleaning off their solar panels every day, for example, from their thermal camera, that we haven't seen results for yet, but at some point will be published when there's more time to reflect on all the minutia of the eruption.
All right, well, that does it for me on the questions front. Thanks for the presentation today. Again, we are brought to you by HawaiiTracker.com. If you enjoy this type of content, make sure to like, subscribe. We've had some people have issues with getting notifications, so do click that notification bell. Make sure you get the alert that we're going live or anything like that. So until next time, back to you, Phil.
All right. Yeah, mahalo. There is one more thank you we want to give, and that's to the recent grant that we were awarded. So I'll just add that this program is brought to you in part by a grant from the Hawaii Island Strong Fund of the Hawaii Community Foundation in partnership with the County of Hawaii. So we're very thankful to the county and the Hawaii Community Foundation for partially funding our updates that are intended to keep our community resilient and strong and able to respond in eruptions should it happen in any inhabited areas. Right, so mahalo you guys. Mahalo Dane for keeping with the chat and answering questions online. To remind you guys that Dane is premiering his new episode of his Drones On series recapping the 2018 eruption. That is coming up immediately after this. And otherwise, mahalo for joining us. Mahalo for your support. Every you guys have donated in all different ways. We really appreciate it. For Dane DuPont, I'm Philip Ong. Aloha, everyone.